Hello and welcome to a new webinar here at FLUXANA. My name is Konstantin Brentgens. Just need to, okay, I think I got it all arranged. And yeah, today's topic is pressed pellets. We'll talk about the techniques used and their application to your analytical task. And we'll go over some examples on how we utilize it here in FLUXANA in our laboratory. FLUXANA, being a manufacturer of fusing machine, obviously does a lot of analytics on fused beads, but we do quite a lot of press pellets as well. And yeah, we also have the presses that we sell. So yeah, let's get into it and see where it leads us. Just need to make sure is this one. Yeah, that's the active monitor now. For those of you who are familiar with our usual layout of these applications, we usually go over these 4 steps. We talk about the sample, the preparation, the analysis, and the results. Today we will only focus on the left side. So we'll start with the sample preparation this time. We'll do it a bit out of order today. So what kinds of sample preparations do we have? Well, we'll talk mostly about pressed pellets, but before we go into that, there is a quick side note here about what else we can do with powder samples. And well, powders you can analyze as a loose powder or a fused bead, and then obviously as a pressed pellet. And we'll just cover the basics here real quick. I don't want to go into too much detail, mainly because there is another webinar that goes into all of these details. You can find it on our homepage, and I think it's on YouTube as well. So if you're interested in the comparison in a more depth, yeah, just go to that. I think there is I think on one of the next screens there is a little reminder when it happened. As always, if there is any questions, feel free to type them in the chat. We will address them at the end if there is still time. Otherwise, if there is no time for that, we'll get back to you by email and just figure out any questions that arise. So yeah, when it comes to powder analysis, the easiest way to do this is just treat them as a liquid, basically. Put them in these sample cups, which are closed off by a thin film at the bottom, and then we analyze it. That takes like 2 minutes, and it's more an overview thing. Yeah, again, don't want to go into too much of details, but this creates some problems with density and light elements, and also the film absorbing our analysis signal, our fluorescence. So it is quick and dirty, but there are, let's say, better ways to analyze samples and get more precise results. For example, taking the same powder and making a pressed pellet. The advantage we have is that we get a more defined density, which helps us with the repeatability of analyses. We get rid of the air that is within all these particles. It takes a bit more effort, but it's still very quick compared to the loose powder. Like it's a difference of like 2 or 3 to maybe 5 or 6 minutes. So it's in the same area. It can be done very quickly. There are even automatic machines that do this for you. So it's still quite fast, and it improves the accuracy compared to the loose powder. And yeah, the density is important because of these particle effects. You might be familiar with this picture. We used this a lot in the other presentations as well. But basically, when you're looking at the X-ray fluorescence, you usually don't analyze the whole sample, but just the layer of it. And the layer depends on which analyte you're looking at. Heavier elements have a thicker layer, while light elements have a very thin one. And then the matrix of your sample also plays an important role. The heavier the matrix, the more the smaller the the layer gets an average. So when you're talking about particle effects, this affects your analysis results. So to start with, and I think this again is maybe a general thing, when we are talking about analysis of powder samples, the first thing we want to have is a fine powder. This will improve our homogeneity and distribution of the particles when we're doing a loose powder or a pressed pellet. And it will also make it easier to dissolve the sample in the fusion. So one of the first preparation steps you always take with the powder is just crushing and grinding them. Depending on what state they come from, the process plant or whatever, the first thing you want to do is get it into a fine powder. And so grinding is usually the first step. And that is an interesting thing because we can use the grinding step of our sample to introduce a binder, which then later helps us to press. So here is an option or an opportunity to be really efficient with the preparation. As an example here, if we are looking at these big ring and plug mills, you can use the Celeox or Boreox tablets, just throw them in there, and that helps you with grinding it down faster. And at the same time, you add a binder to the sample, which will help you later to make nice pressed pellets. So this, again, helps you to make an efficient preparation for your sample. One thing to keep in mind is that if you're grinding the sample, you will always contaminate your sample material with the inlay of your grinding vessel. And in this case, the picture here, that's a zirconium oxide, you can see from the color, but there is also tungsten carbide, for example. And so depending on what the critical analytes are for your sample material, you want to make sure to use the right inlay, and just be aware that there is a bit of contamination with the vessel, and just be aware of that when you're looking at the results. There is this, I think we'll come back to that. There is this example of iron being a critical analyte when it comes to glass manufacturing, because it affects the glass. So people who do glassware, they want to make sure that their silica carrier is extremely low iron or no iron at all. So if you're grinding that in an iron vessel, it gets a bit problematic. Last sheet about the comparison, and as I said down here, you can find those on YouTube. There is a comparison between pressed pellet and fused beads. When it comes, fused beads you can use fused beads to make like a nice disc out of your powder sample by dissolving it in a borate and then casting it into a glass disc, basically. In terms of effort, this is a lot more. A fusion usually takes, let's say, 25 minutes just for the fusion, and most of the time there is a balancing step before and even a pre-treatment of the powder. So the whole process maybe takes an hour compared to our 5 minutes of the pressed pellet. But we trade that for a higher reproducibility because we get rid of these particle effects. So it's always a kind of trade-off. But just, if you're interested in more details, check out our website. So we'll go into our main topic for today. When we're looking at pressed pellet, what do we have, or what do we want, and what qualities do we want, and what qualities do we have? First of all, we always want to pick a procedure to get a stable pressed pellet, which allows us to be measured in vacuum. When it comes to the X-ray side of the analysis, you always have to choose the atmosphere. And vacuum is ideal, but when it comes to liquids and also to loose powders, using vacuum is not a good idea because it evaporates. So what you want to use then is helium or air as a protective atmosphere when dealing with a loose powder. At least that is how we handle it. Basically, a loose powder in a cup is the same as liquid for us. So our machines, our spectrometer, switch to helium atmosphere as a protection. And the pressed pellets we make, they should be stable enough to be measured in vacuum without problems. So that's the idea here. Compared to other techniques like diffuse bead, it is quite low effort. It's really fast. I mentioned before, there's even automatic machines that do the milling and pressing in one step. So there's options for that as well. In our lab, we do it all manually. So we have the balancing, the mixing, and the pressing. But let's say one press pellet is let's say 5 to 10 minutes in total. So it's quite fast. It's quite fast. The defined density is what we want to achieve, which helps a lot with the repeatability of analyzers compared to the loose powder again. And yeah, in measurement, we don't want it to powder or break or contaminate the X-ray in any way. We want it to be measured in vacuum and come out the same as it goes in. A question we get asked a lot is about durability of these preparations now, and the official term is always press pellet is only for one measurement, though in reality that means you can do multiple measurements, but you can't store them for days or weeks. The preparation itself will age quite quickly because the powder will take moisture and other things. So I think a good approach to this is do the preparation, measure the samples as quick as possible, and then once you've got your results done, just get rid of them. Don't store them like you would other preparations. And if you want to store the sample for later use, my recommendation is always use the powder. The powder you can store in the press pellet is really quick. So if you want to store it for later questions or later things, just store a bottle of the powder and not the preparation. Speaking about the samples, let's have a look. I think this will be actually, yeah, I already kind of teased that a bit. So obviously we're talking about powder, but we're also more specifically talking about fine powders, and how fine we always recommend to have the particle distribution below 100 micrometers, just to make sure that, again, we don't get into these particle effects or they don't overtake us. Another important thing is the powder needs to be dry. Our laboratory is quite lucky in that regard. We usually receive our analyzer samples in a little bag or a little container, which is already, it's been milled, it's been dried, it's been kind of prepared for analyzers, prepared for preparation, so to say. But if you are looking at like the industrial laboratories, people or laboratories working on site with the industry, they get samples from outside, from the dumpage, from the containers, from a transport, or maybe from a conveyor belt. So it's quite different. Those samples can be exposed to the elements. They can be like sitting in the rain, basically, which can make them quite wet as a powder, and you should never do a press pellet with a wet sample. That's just a mess. It's compressing a liquid, and it's also kind of smearing in your dye. So if you get a sample from outside, just make sure to dry it before you do the actual pressing. Otherwise, you will not be happy, and you will have a lot of cleaning to do. And also one thing to keep in mind is that most samples need a binding agent. There are a few materials that go without binder, but a binder usually improves this. So even if your sample is sticky enough to bind by itself, using a binder is not, how to say, discouraged. It actually helps them to keep stable. Keep in mind, we want it to be stable to survive a measurement in vacuum, or to be exposed to the vacuum chamber in our spectrometer for maybe 10-15 minutes. So we want to make sure that it doesn't break or that it doesn't duff off. What's the binder? You know that from your vacation when you're on the beach and you want to build a sandcastle, you just need some water, which is in that example, the binder, but not in our case. In our case, we use different binders. They are not liquid, mostly they're powder. So we'll have a chat about those a bit later. But yeah, there is different ones available. Here are the FLUXANA ones. We have the Seriox, Teleox, and Boreox. Just FLUXANA trade names for common chemicals. We'll have a look at those later. What else do we need? A press, obviously, and a pressing die. So we have our equipment here, the automatic one that has this spring-fed pressing die, which has a automatic release, and then here the manual one, which fits in all the other modules. I think this is the smallest one, and this is the larger electrical one. Obviously, this one is manual, and this one has a little pump for an oil circuit that does the pressing for you. So depending on how much samples per day you do, you would choose one or the other. Yeah, and the pressure for pressing usually is displayed in tons. Another frequent question when it comes to the pressing dies, they come in various diameter to fit basically the position on your spectrometer. There is 32 millimeter for a disc, or 40, or a few others, but 32 and 40 are the ones that we mainly use in our laboratory. And there is a maximum pressure that you should observe here. In case of our preferred 32 millimeters, the maximum pressure we apply to this die is 25 tons, which is quite a lot. I think our actual preparation document says maximum pressure 20 tons. So this is the one that is for the equipment. You should not overpress a pressing die because that will actually damage it. So the actual pressure you apply to a certain sample depends on the material and your recipe. So sometimes it takes a bit of working out. We will have some examples later to give you an idea. And yeah, feel free to reach out to us if you want to have like a recommendation for a recipe. Going into the examples now. So we do want to make a pressed pellet from our powder, and we'll go over these different ways or methods to do it, procedures to do it. The first one, I said already, is direct pressing, which we do in our laboratory, for example, for our quality control of the binders themselves. Each lot of the binders get we quality control them and look for impurities, just to give them a specification for each individual lot number. And yeah, obviously we just take the powder. We take like 5 grams, we make a pressed pellet, and then we analyze that on the X-ray to see if there's any stuff in there. And yeah, that's basically it. So very quick. The binders that we sell are here. Keep in mind there are more available, but these are the ones you get from FLUXANA. So we have the Seriox, which is the wax. It has different trace names like Höchstwax, Licowax. It's a very nice and clean binder that has no grinding aid properties. So you should never put that in your powder and then do the grinding. It will actually clog up your grinding vessel. So this comes after grinding. You need a fine powder to mix with that. And then it's a very nice grinder because it acts like a glue. So we actually prefer to use this one in the laboratory, mixing that with the sample, pressing it, and we get nice and stable pressed pellets. When doing the quality control, we need to make sure not to press too much, to put too much pressure on the die, because that will actually clog it up. So I think this one goes only up to 10 or something. Otherwise, you can't get it out because it's stuck. Boreox is cellulose. It comes in powder and these little tablet forms. That is a grinding aid and a binder. So you can actually put these tablets in your vessel, as mentioned before. Just do like 20 grams of sample, five tablets, and just grind them and mix them with the binder in the same step, which is quite nice. There is also powder available if you want to mix it by hand. And yeah, the next case or next example for pressed pellets is using mechanical stabilization, like these aluminum cups. They are disposable. You only use them once and you press the powder in there. And then obviously one side and the sides and the top basically are covered in aluminum, but the other side you can measure. But yeah, keep in mind they're one use only, and they help with stabilization for one, but they're also making your pressed pellet a lot easier to handle for auto samplers. In our lab, we use these kind of claw or suction device auto samplers, and they have trouble with pressed pellets because of the rough surface. They tend to drop them. Using the aluminum cup helps a lot here. Though we mostly don't. We don't really use them in active. We just sell them for automatic laboratories. When we do the pressed pellets, we put them in cassettes, which then go in the X-ray. So there is not a problem with the auto sampler. A similar design is using rings. The difference being the rings are reusable. Having a sample in here, you do the measurement, you just remove the sample afterwards, maybe brush them off or wash them off with some cleaning alcohol, and then you can reuse them. They come in various different sizes depending on press equipment and XRF equipment, and we actually do these regularly for our geo sets. There is like a pure FEO sample in there that gets pressed into these, I think this is brass ring, and then there is another one as a blank that gets in there. So we do these regularly just to put them in sets and then sell them. The last one, or not the last one, but this one, the pressing with binding agent, that is actually what we do with real samples. So not real samples, what we do with most of the samples that we get. So this is by far the most press pellets we do is mixing them with a binding agent and then pressing them. A few ideas, just to give you a few examples as when we do it. If we get a complete unknown material that we know nothing else about, so we have no specification, no idea what it is, then the first idea is always to do an overview analysis on a pressed pellet, just because it's quick and it gives us a semi-quantitative idea about the composition of the material. So if somebody comes with a bucket and asks, hey, what's this powder? That would be our first idea, just doing an overview analysis on a pressed pellet to see what analytes are we dealing with. Another example, which is actually one of our accredited analysis, I think, is geosamples. So that basically, what's geosamples? These are just geosamples is basically, I've got the German norm here because there is no real translation. So I just took the German one, but basically this is soil samples and there is a norm for it when it comes to the soil sample itself and contamination by environmental effects. So this is basically your bucket full of dirt that you would analyze. And the norm is quite interesting because this norm combines fused bead and pressed pellet analysis, and in a very interesting way, you would do the main component of the minerals basically you would do by a fused bead, and then all the trace components, this area here, you would actually do by pressed pellet. Usually, you would think from the analysis accuracy, it would be the other way around. But in this case, when we're looking at these these are basically contamination elements, if you want to call it that, and they should not be in there. So you're looking if there is something in it that doesn't belong there, more or less. And if you do that in a fused bead, you dilute the sample and the signal just gets too low and you don't get really good results. So the practice has shown that doing this in a pressed pellet with a more concentrated sample just gives you better limits of detection, and that's what the method is about. So we have a good example here of combining different techniques to get all the information about the sample that you want. Another application or another usage of the pressed pellet method is when we're looking for volatile elements, and these are our focus of interest. Fluorine and chlorine are a good example. If you're looking at calcium fluoride, for example, as a raw material, doing that in a fused bead is not a good idea. just because the high temperature just gets rid of it, and it's not really repeatable in the fuse speed. But in a pressed pellet, it's better. It's just like you have the particle effects, but you have not the volatilization effect. So the compromise is just better, and the results show that when you're looking at these ones as your main analytes, it's better to just go for a pressed pellet. Just because, yeah, in a high temperature process as fusion, you just lose them. Now, how would you do pressed pellet? We have the procedure the procedure from our lab here in detail. So in FLUXANA for a 32 millimeter, we would use 4 grams of the sample, and we would mix them in these little plastic containers. The little balls you go in there just to create some more movement. So yeah, they go in there. So we just balance the sample and the Cereox binder in this case in there. We put a little ball, and it goes on the table, and it just shakes for 2 minutes. After that, this is transferred to the press. I think that's the next. Yeah, we do grinding, mostly not. Most samples we get are already below the 100 micrometers I mentioned. We do the belling, the weighting. We do the mixing of the sample. We like using pellet films on our equipment. There's a sheet about that next. And the aluminum cups are optional. You can, as I said, we rarely use them. We like to have pressed pellets that you can measure from both sides. And sometimes we actually do that if we see that, you know, just to have two measurements, 2 surfaces to measure and see if there is a difference. The mixture then gets poured onto the pressure plate. Another one is added. We put it into the press, and the results hopefully is a nice pressed pellet. Speaking about the pellet films, what are those? These are basically these little pre-cuts that fit the diameter of your pressing die. And yeah, we put them on these little plates that then go in, and they avoid sticking and contamination. I mentioned before the iron and the iron in the silica oxide that the glass industry, that problem that they had. And we tried to kind of avoid them with that, but it was actually not enough. So we only had like the help with the sticking problem, so to say. In the end, what ended up happening in that example is they used a completely different die from a different material. So we made them a tungsten carbide pressing die as a sort of extra die to avoid a contamination with iron. Generally speaking, for our laboratory, we do have that die available, but most we use the stainless steel one, and we like the pellet film most because of the anti-sticking effect that they have. The worst thing that can happen is if you invested the time already to make your mixture and so on, and then you make the press, you try to press the pellet, and you take it out, and then at that point it breaks because you have to get it out of the die. That might mean your parameters are a bit off. Let's say you apply too much pressure to get it. So maybe try using a bit less pressure. That would be something to check, but usually just having the pellet film prevents that because it makes it a lot easier to get the samples out of the die without them breaking. So we like those a lot. We recommend using them just to have it more easy to handle. The last example is, I mentioned before, we need quite a lot of amount. We need a lot of samples to make a pressed pellet, like 4 grams for 32 to get a good thickness. So if you do not have that much sample available, what you want to do is the so-called baking or the pressing onto a baking material. This used to be done with boric acid a lot, which we don't sell anymore because it's considered toxic. So we use this one with Boreox now, and the idea here is to simply, again, German instruction, ignore those. I'll take you through them. You use these little tool here to first prepare your pressing die, and then first do the little amount of sample you have in there with this little filling tool, and use the stamp to distribute it on the surface. And then basically you fill the rest up with a lot of Boreox to make the frame, to make the baking. And then you put it through this pressing, and the results will be something like this. Well, this one is broken in the middle, but you basically have a thin film of your sample pressed on a lot of borax as a carrier. And that makes it, again, very stable and easy to measure. And obviously, you would measure it in this case from the top side, but that also means you analyze your sample as a whole. So if you have very little amount of sample available, let's say half a gram or something, this method will help you to still get a good analysis with press pellet. Summary. Let's summarize what we've talked about. Well, yeah, the press pellet method is a way to prepare powders, and it's fast and low cost. And basically, the fast one makes this the ideal method to prepare samples for process control, where speed is everything. For quality control, yeah, it can work, but that there's others available. But for process, there is yeah, it's the chosen method. Depending on the sample amounts and the material, you will have to choose a fitting recipe. There is various ways you can do that, but you want to choose one that fits your material and amount. One advantage we have in analytics is that we have basically the pure sample. It's not really diluted by any agent like in other methods, and so this helps us, especially with the light elements. In details, you always have to try out the performance and see if it matches your expectations or specifications. And in some cases, as I mentioned, the GEO method, we actually use both, and we combine results from multiple or from different analysis techniques to get like the best results possible. Okay, time's up. As usual, I'm like a minute over. I did see there are some questions. I will get back to them via email. Don't worry, via email. We do have the questions in here, and I'll go through them. But today, I would like to say thank you for your attention. This was actually the last webinar for this year, so I hope to see you all next year. And yeah, thank you and goodbye. Have a good day.